1,200 degrees Celsius. At this temperature, rock turns into liquid fire, rubber tires melt instantly, hydraulic lines explode, and human skin burns in seconds. Most machines are built to move dirt, but when a volcano erupts, dirt becomes death. No standard excavator can survive here. Today, we take you inside the kill zone. We will analyze the engineering miracle designed to work where nothing else can survive. This isn't just a machine. It's the only thing standing between a city and total destruction. Welcome to Machines versus Nature. To understand why this operation is so difficult, you must first understand the enemy. A volcano is not just hot lava. It is a physics nightmare. Many people think lava acts like water. This is false. Lava is molten rock, and it is 3 times denser than water. Pushing a wall of lava is not like pushing mud. It is like trying to push a moving mountain of wet concrete that is also on fire. The resistance against the blade is immense. If a standard bulldozer tries to push cooling lava, the transmission will shatter under the load before the tracks even slip. So, how do you build a machine that can fight a volcano? Meet the modified heavy assault dozer. To the untrained eye, it looks like a standard Caterpillar D11 or a Komatsu 475, but look closer. This beast has been stripped and rebuilt for war. Let's look at the armor. The most vulnerable part of a machine is its underbelly. On a normal construction site, the heat comes from the sun above. Here, the heat comes from the ground below. If a machine drives over a fresh lava flow, the radiant heat can cook the engine oil from the bottom up. To prevent this, engineers install thick double-layered steel belly pans coated with thermal ceramic barriers. These act as heat shields, reflecting the radiation back into the ground. Next, we have the hydraulic nightmare. A modern excavator runs on high-pressure fluid, pumping at over 4,000 psi. Under normal conditions, this fluid gets hot. In a volcanic zone, it gets critical. If a hydraulic hose bursts near lava, the atomized oil creates a flamethrower effect, instantly engulfing the machine in a fireball. To stop this, every single rubber hose is wrapped in fire sleeves, a chaotic weave of fiberglass and silicone that can withstand direct flame contact for short periods. But what about the metal itself? We assume steel is invincible, but at 600 degrees Celsius, standard steel begins to lose its temper. It becomes soft. If an excavator bucket digs into semi-molten rock, the teeth can literally deform and curl up like plastic. To fight this, the buckets and blades are fitted with sacrificial wear plates made of exotic chromium carbide alloys. These alloys are designed to maintain their hardness even when they are glowing red hot. Now, let's talk about the worst-case scenario: fire. Despite all precautions, sometimes the machine catches fire. In a remote volcanic zone, there are no fire trucks to save you. You are on your own. These machines are equipped with automatic Ansel fire suppression systems. Sensors in the engine bay detect a spike in temperature. Within milliseconds, nozzles spray a chemical powder that sucks the oxygen out of the air, suffocating the fire before the operator even realizes there is a problem. But technology has limits. Let's go back to the 2018 eruption in Hawaii. This was the ultimate test. The situation was critical. A massive river of lava was threatening a geothermal power plant. If the lava hit the wells, it could release deadly hydrogen sulfide gas, turning the island paradise into a toxic wasteland. A team of operators was deployed. Their mission was impossible: build a berm, a giant wall of earth to divert the flow. They couldn't use remote control because the thick electromagnetic interference from the ash clouds blocked the signals. They had to go in manually. Imagine sitting in that cab. The ground beneath the tracks was so hot, it was glowing. The vibration was constant, like a never-ending earthquake. Inside the cabin, the air conditioning units were fighting a losing battle. The operators reported that the rubber seals on the windows started to melt and get sticky. The metal tracks groaned under the thermal expansion. The strategy was risky. They used a technique called the cold roll. Bulldozers would push a layer of cold dirt over the lava to create a temporary bridge. Then, they would drive over it to pack it down. If they moved too slow, the heat would transfer through the dirt and melt the tracks. If they moved too fast, the dirt bridge would collapse, dropping the 100-ton machine into the molten river. Suddenly, a crisis. The wind changed direction. A cloud of sulfur dioxide enveloped the machines, blinding the cameras and sensors. The operators were driving blind, inches away from death. The lead operator had to rely on radio commands from a spotter helicopter hovering above the smoke, pushing thousands of tons of rock. The engines roared to their limit. The stress on the final drives was catastrophic, but they kept pushing. With moments to spare, the wall was completed. The lava hit the barrier, piled up, and then it turned away. The power plant was saved. When these machines came back, they were destroyed. Paint peeled off, sensors melted, steel tracks warped by the heat. Some had to be scrapped entirely. They sacrificed their mechanical lives to save the city. This brings us to a final question. Is it worth the cost? A machine like this costs over $2 million. Repairing it costs another $1 million. But when you compare that to the cost of a power plant or a town, the machine is cheap. It is a disposable hero. Nature will always be stronger than us. Volcanoes will always erupt. The earth will always shift. But thanks to extreme engineering, chromium alloys, and the bravery of these operators, we have a fighting chance. What do you think is a tougher challenge? The crushing pressure of the deep ocean, or the melting heat of a volcano? If you enjoyed this deep dive into extreme machinery, hit the like button and subscribe to Machines vs. Nature. We post new documentaries every week exploring the limits of human engineering. Thanks for watching.